Hello and welcome. So today we have this following differential equation to try to solve. Dy dx plus 2 over xy is equal to 19y to the fourth. So to solve this, first off is recognizing that this is a Bernuli equation. So to solve first, we're going to treat the right side as equal to 0. So we're going to solve for y prime plus 2 over xy is 2 over x times y is equal to 0. That goes to y prime is equal to negative 2 over x times y. Right, solve that homogeneous differential equation. You get 1 over y dy is equal to negative 2 over x dx. Take the integral of each side, raise it to the power of e. So we get, ln y is equal to negative 2 ln x, which is the same as ln x to the negative 2. Raise everything to e to the power of that. Summary of y is equal to x to the negative 2. And we're going to call that y1. So y1 is equal to x to the negative 2. Now that we have our y1, we're going to say that the function y that we're trying to solve is equal to some function u of x times this y1. So then we could say that y prime is going to equal u prime times y1 plus y1 prime times u, right? So now we're going to take our known y1, leave u as this unknown variable, and solve for that original equation that we were given. So dy dx now becomes u prime times x to the negative 2 plus x to the negative 2, take the derivative of that, it's negative x to the negative 3 over 3, right? Over 2, right? Times 2, because it's a derivative, not an integral. Right, so negative 2 x to the negative 3, and then plus that 2x to the negative 1 times y we now know as u times x to the negative 2. And that's all equal to 19 u times x to the negative 2, all to the power of 4. So that becomes u to the 4 times x to the negative 8. So that's that big equation that we have right there. Annoying to work with, but the negative 2x to the negative 3u term cancels out with the 2x to the negative 3 times u term. And so now we could take that x to the negative 2 on the left side of the equation, multiply that over to the right side of the equation, and that gives us u prime is equal to 19 u to the 4th x to the negative 6, right? Now we're going to solve this linear equation, or this homogeneous differential equation. And so split it up, we get u to the negative 4 du is equal to 19x to the negative 6 dx. Take the integral of both sides. What we get is negative 1/3 u to the negative 3 is equal to negative 19 over 5 x to the negative 5 plus some constant c. Okay, now next thing that we do is we can multiply across that negative 1/3. So we just are left with u to the negative 3 is equal to 57 because the negatives cancel out. So 57 over 5 times x to the negative 5th plus a new constant. You could call the old constant c1, the new constant just c. Okay. Now, the next thing that we're going to do here, very elegant move, going to take the cube root of each side. Well, we're going to take each side to the power of negative 1/3. So, doing that, we get that u is equal to equal to the cube root of 1 over that 57 over 5 x to the negative 5th plus c. Right, that's what we have for our u. Now, what we're going to do there is we're going to substitute back in what we're going to substitute back in u for y. So right. So using the equation that we had earlier, where y is equal to u times x to the negative 2, we could say that y times x squared is equal to u. So then you could plug that in for u and then divide by x squared on both sides. So we're left with y is equal to x to the negative 2 times that cube root of 1 over 57 over 5 x to the negative 5 plus c. Right? And that's a squared and then a cube. So, next thing is we need to solve for those initial conditions. So we have y of 1 is equal to 1. So plug in 1 for y's and 1 for x's. Cube root of 1 over right, so for this equation to be equal to 1, that c needs to add together with 57 over 5 to equal to 1. So you know that c needs to be negative 52 fifths. So could rewrite our final equation, y is equal to x to the negative 2 times the cube root of 1 over 57 over 5 x to the negative 5 minus 52 over 5. All right, and that right there is what we get. Thank you very much.